Okay, thank you very much, Toda-san, for introduction. So first of all, it's a great honor to be here today, and I really appreciate it to have this opportunity to join this excellent conference. Thank you very much. So I'm Tatsujiro, so please call me Tatsu, and Tatsu Sakamoto, and I'm group manager of Hitachi GE Vernova. And I'm also working for acting the project manager for BWRX-300, and especially for the standard design. And so I'm very closely working with our US alliance partner, GE Vernova, Hitachi. Thank you very much. Okay, so here is the contents. So let me walk you through the contents. So firstly, I will introduce Hitachi GE Vernova. So I will talk about who we are. And the second, we talk about key feature of BWRX-300. And the next, I will talk about Canada. So right now, we're focusing on the Canada OPG project, Darlington new nuclear project. And then I will talk about HNE's contribution to BWRX-300. So HNE's contribution, I will talk about that. And after that, I also introduced about the current global deployment of BWRX-300 momentum. Then finally, I will wrap up with conclusion remarks. Okay, can I use this mic? Okay. So this slide, firstly, I will start my presentation from introducing our company and also our alliance partner, GE Vernova. So you can see the upper left box. So we made an alliance in 2007 and for the global nuclear business. And so this green side, this is a US entity, GE Vernova Hitachi. So GE 60% owner and Hitachi 40%. On the other hand, in Japan, my company, Hitachi GE Vernova, we also share the company stock. So GE Vernova responsibility for leading the business global, and our company responsible for leading the business in Japan. Then, as you can see, the bottom part. So both company has unique strengths. Then this alliance, but 2007 we made an alliance, but before, prior to that, we have maintained the cooperation alliance, cooperation partnership over the 50 years for nuclear business. And in 2007, we made an alliance. So this alliance enables both synergies and complementary capability. So complementary capability means I talked a little bit about this. So both company has unique strengths. So GEH has plenty of experience to develop nuclear system design, and also global supply chain and licensing and global nuclear experience. And on the other hand, and my company HNE, we had a continuous construction project and also maintenance project in Japan. So HNE has strengths include design and manufacturing, construction, and commissioning support, and also integrated EPC planning. It means we have a lot of experience for construction in Japan. And so next slide, I will talk about our company's business portfolio briefly. So this is our company's portfolio. So our company covers almost whole nuclear business, lifetime business field in Japan. And so you can see new build. So we had a lot of experience for new construction. So JICC number 2, this is ABWR, our Hitachi GE Vernova's design. And it's already completed construction, then operated before Fukushima accident. And now it's shut down. Then OMA number 1, this is ABWR, this is under construction status. But unfortunately, after Fukushima, it's suspended to move forward construction project. but now discussing when we should start. Then I think we always welcome you guys visit my company, Japan. And this is unfortunate to suspend the project, but only one positive thing is during the project, we stopped this project. So my factory stored a lot of already completed reactor internal component. So we stored long term. So only good things is good for visitor. You know, it's a very rare case can see the reactor internal component. So we always introduce the guest very closely. Then it's kind of nuclear, museum. So this is only good things. So we always welcome. Please come to our office and the factory. And also we work for plant service, and we now working for safety enhancement for preparation for the restart, and also we working for the Fukushima decommissioning work and fuel cycle. In this morning, so Mr. Kawamura introduced this 6カ所 reprocessing plant project, and we also working for this. And also we supply the fuel. Hitachi has a design, and we manufacturing spent fuel cask. And finally, because of the alliance corporation, and also I belong to the global project management team. So this is my focus area, overseas business. So we always working with GE Vernova Hitachi. And now my company also focusing on the BWRX-300 project as a top priority project. Okay, so from this slide, I will talk about key feature of BWRX-300. But prior to that, I would like to mention about we are sincerely appreciated Fermi Energia selected BWRX-300 as for the future deployment in Estonia. And this was made in 2023. So we are so excited, and we are very grateful to be contribute to future Estonia's energy security and climate goal. So let me talk about the key feature. So the BWR SMR, BWRX-300 is BWR SMR with 300 megawatt. And this is 10th generation of BWR. And I will talk about a little bit about this in the next slide about the evolution of BWR history. Then the second, as I mentioned already, GVH, so we call it GVH, GE Vernova Hitachi, and Hitachi GE Vernova. We closely working, and every morning, every night, conference call. So very closely. I had a conference call this morning, 4 o'clock. So everybody working very hard. So this is key project. So everybody understand this is very important. Then, but this is very good example to show the great example to show the leverage of this alliance. And we collaborating closely by leveraging both companies' strengths. And the third, so BWRX-300 is US NRC licensed ESBWR revolutionary design. And so our BWRX-300 applied natural circulation and also passive safety. So this design was certified in the ESBWR design in US NRC. And the next cost, I will talk about cost efficiency, design to cost. So we started with this concept from the very beginning of design phase. So we started from this concept. And then as a result, we achieved to simplify the design. Then it's resulting in the reducing the cost. And the next, fifth, so number 5 and number 6, these two areas are the most area that HGNE, my company, can contribute specifically. And I said utilizing proven and reliable component. It means right now, I will talk about this later, but Hitachi GE is awarded to provide key component, reactor internals, and FMCRD, and also HCU. So these three components is key component of the nuclear island. And because this is the key item, as I said, and to reduce the first kind of, first project, it's key concept to maximize using the proven design, a proven supply chain, right? So this is important. And also constructability. As I said, HNE has a lot of experience for the construction, and that's especially for the modularization approach. And so we, from the beginning of the design phase, we consider the constructability with modularization strategy. And this kind of constructability has been integrated into the design from the design phase. Okay, so this is evolution of BWR design. So as shown in the green streamline, so these design, most of them are commercially deployed in globally, US, especially in US, and also Japan. And so ABWR, from BWR first to BWR6, and ABWR deployed in Japan. Then on the other hand, you can see the left side in the purple line. So natural circulation reactors has been developed in the separate streamline. Then, so right now we focusing on the BWRX-300, and considering the social demand for the lower construction cost and also safety enhancement. So we decided to apply the natural circulation design and also passive safety, passive cooling. And also, as I said, the proven design is key important. That's why we introduced natural circulation and the passive safety design on top of the commercially deployed BWR design. So kind of mix and combination. Okay, so this slide, I will explain one by one. So also this slide was introduced in the Mr. Kawamura's presentation in the morning. And you can see the upper left. So this RPV integral isolation valve. So this is key design concept and key part of the LOCA, so-called LOCA, so loss of coolant accident due to the pipe break, mitigation strategy. So this isolation valve is a key strategy for LOCA mitigation, LOCA risk mitigation. And this valve was attached by the flange directly to the RPV and isolate the RPV automatically, and also stop the leakage from the vessel after the downstream pipe break quickly, automatically. And so then we achieved reducing the LOCA risk drastically. Then that's why we can reduce the amount of the safety system, because we could reduce the risk. And also, I will talk about isolation condenser system. And this is isolation condenser system is a passive cooling system. And this system can be operated 7 days automatically without power and without operator's action. So that's why this is a passive safety system. Okay, then I will talk about cost reduction, and I have already a little bit talked about this, because because of this innovative safety system, we could successfully reduce the amount of the safety system. Then it means, reducing the amount of the safety system means we can reduce the amount of the piping and the system. So that's why we can achieve the smaller containment. So BWRX-300 compare with the conventional previous design, such as ABWR, BWRX-300 is small, and the material volume is much smaller than previous deployed reactors. And flexibility. So BWRX-300 also capable for the load following operation. So from the BWRX-300 can maneuver from 100% to 50% with a 0.5% per minute ramp rate. And also sighting, because sighting is very important for make a decision for the location for this BWRX-300 plant. And as you can see, this is an example. Previous commercial plant, EPZ is emergency planning zone, is typically 10-mile radius, but BWRX-300 target to this EPZ area align with the site boundary. And you can imagine that to get the imagine of the site size, plant size, we always say our BWRX-300 typical site size is almost same as football soccer court, so quite small. And lastly, I'll talk about short-term construction. And so this is one of the areas Hitachi GE contributed, and Hitachi GE has a strong record to complete the construction in Japan, and average is around like 40 months, like around 36 months and 40 months, something like that. So we have this achievement is based on our modularization strategy. So we provide our experience and to GVH, then we join this strategy in the early phase. Okay, so next topics, I will talk about the OPG project. So as almost everybody may know about this, 2023, GVH, OPG, and Atkins Leary's and the Canadian construction company Aecon signed a contract for deployment of BWRX-300 at OPG Darlington site. And now everybody so excited, and all of the not only for this 4 company, including Hitachi GE, everybody is proud of this project, this pioneering project. And so right now, the site preparation work has been completed, and including 4 units. So OPG announced they pursuing the introduce 4 units, not only for one unit. And also key long-term procurement completed, including the component provided by my company. And the Ontario government, as I said, they announced 3 additional units will be introduced. And then finally, this year, April, Canadian regulator finally issued a license to construct. So this is indicate the like indication to go ahead construction. Okay, this is then. So this is a big milestone. So finally, May 8th this year, Ontario government made an announcement. Then they approved to start construction. So construction started May 8th. So this is a very big achievement. And in this announcement, Ontario government mentioned that OPG's budget is $20.9 billion Canadian dollar budget for unit. And also the first unit cost is 6.1 billion. And in addition to that, also 1.6 billion for common means common facility, common for unit. And in this announcement, government also mentioned that we expect to reduce the cost in the following unit 2, 3, 4, right? Considering the improving the efficiency, it means right, more efficient procurement. Each vendor also can reduce the cost because of the repeated effect. And also, the first unit will be in service by 2030. Okay, so from this slide, I also I introduced about Hitachi Vernova's contribution. And so I separated two parts. So first part is as contribution as joint developer. So we dedicate to support engineering support, such as mechanical design and RPV. So mechanical design include RPV support and reactor internals design and containment vessel design and FMCRD. And also we supported the system design, so nuclear island system design and safety analysis. And finally, last one is construction support. And also Hitachi has a test facility for the natural circulation. So we utilize this facility for demonstrate the BWRX-300 natural circulation condition. And contribution as a subcontractor. I will talk about this in the next slide more, but HNE is awarded for these three components. And also we working for construction support. So just right after the Ontario government announcement, May 9th, HNE issued an announcement about the we are awarded for key component, reactor internals and FMCRD and HCU. This slide shows the global deployment of BWRX-300 momentum. So I talk about a lot about Canada project. So and also in addition to OPG, Sask Power also announced to select BWRX-300, and also US TVA is one of the party to implement the BWRX-300 standard design. So they actually invested. So they are partner. Then they also committed to BWRX-300 deployment. And Duke, AEP, and other utility also showed strong interest in BWRX-300. So in addition to North America country, we also received a strong interest and a strong momentum from across Europe. And as I said, Fermi Energia selected BWRX-300, and Poland, OSGE also committed to proceed with BWRX-300. They also invested, and Sweden and Finland. So this shows indicate the strong. We receive strong indication for the recognition from the global market. BWRX-300 is leading the SMR solution. Okay, so this slide conclusion remarks. So BWRX-300 offers strong potential to help achieve 2050 net zero emission target and align with triple nuclear power pledge. And also HNE strategically working with GVH and drive the success of BWRX-300 deployment by delivering engineering experience, critical component, and site construction support, leveraging the long-term decade of Japanese nuclear experience. And the Canada OPG project is key project. Everybody understand about this, and this is stand as the first major SMR demonstration. And this success is very important, and also accelerate the global deployment of BWRX-300. And HG&E is fully committed to supporting this effort. So finally, let me say we are very proud to contribute to Estonia's future energy, also global to achieve the global goal, global climate goal. Yep. Suuru aita. Suuru aita.
Thank you. My name is Kalev Kallemets. I'm from Fermi Energia. I have a technical question. So Olkiluoto 1 and 2, when they went into operation in 1979 and 8, they are obviously boiling water reactors, and they were 660 megawatt electrical originally. Now, after several upgrades, they, with the same RPV, reactor pressure vessel, and the same volume of fuel, they are the same generator, they are producing 891 megawatts electrical output. And after future upgrades, the TVO expects that they will get 80 megawatt more. We have talked to our friends in Canada, in OPG, what their level of hope is, because when you are starting to operate the plant, then you are finding potential, potentials where it is possible to have better steam flow, better efficiencies. So in your experience, is it possible? And if we look at the cost, then the other part of the equation is the revenue. And the more power you're able to produce from the plant, then obviously more economical it is. In your view of the BWRX-300 and its unique characteristic of natural circulation, but also keeping in mind that the United States, they're using higher enrichment rates in the BWR boiling water reactors, is it possible that the BWRX-300 is a little bit more than 300 after there is some time of operating the unit to find the efficiencies? Thank you.
Okay, so unfortunately I'm not engineer, so I don't have actual information. But according to the capability, GVH and the HG&E, we have several options. Then in response to the customer's demand, and there are several options to reduce the operation cost, right? And as you mentioned about, we have some approach to improve the cost efficiency from the design change approach. And I think so. This is a natural circulation reactor. So basically, we need to think about different approach from the like the pump circulating the conventional BWR. But we can also consider the but turbine side is the same, right? Reactor side is different, but there is some space to improve the turbine side. To improve the condenser is key part. So then our alliance partner GVH has a lot of experience but the US is leading. They lead the knowledge to improve the power. A lot of experience for the power upgrade. So they have a lot of expertise in company. So I believe there are several options. And also BWRX-300 consider the reducing the operator. So if we have 4 units, we can have a common facility to operate. And also so there are several future options to not from the design approach, but reducing the operator so that it's contribute to reducing the cost, right? Did I answer to your question?
Thank you for the presentation. My name is Martti Jeltsov. I'm also from Fermi Energia. I know the experience of the construction of the ABWRs. You mentioned 36 months, 48 months, up to 48 months, so 4 years for a large reactor, which I really appreciate. And I've read papers on the modular construction approaches and etc. And you mentioned that you are supporting your alliance partner with the construction approaches. So can you elaborate a little bit more? How do you, in what capacity, how many people from your side are actually bringing that experience to the boiling water reactor X300 project? Are you only, and are you talking in addition to your alliance partner also to the constructor there, Aecon? Because the technology development is one side, but the other thing, and then we saw before also that the majority of the, or most biggest reasons for the delays are actually in the construction part of the building. So how much you support and I would like to even say teach the Western partners in building on time and budget the structures, the concrete. In addition to technology, I don't see too much of a problem on the technology side, but more on the building construction side. Thank you.
Okay. So construction, I think all of the SMR technology, because SMR's M is module, right? So everybody talk about module, maximize module concept, but actually it is not simple. Then Hitachi always closely communicate with Japanese construction company. So we have several major construction company. Then we had a long experience working together. So in our Japanese project, there is no like concrete like package of the modularization plan. We always discuss closely and sometimes customize the approach. Then with our construction company, such as Kajima and Shimizu. So we have a long experience. So we have some sense, right? This is we have to closely talk with, discuss, and make decision with construction company. Then that's why. So right now, from at this moment, as a beginning of the effort, we already dispatched one construction expert to Canada. So we personally send the personnel to one of the most experienced engineers. Then he always every day working with Aecon, because the Vernova and Aecon working very same place. So he is in the middle of the communication, Vernova and Aecon. Then we advise GVH. This is we have to very closely working and make a decision together. And also, as I mentioned, the Japanese construction company also already we invited, and then we got commitment from them. So Japanese construction company also always working with us. Then we have they are considering to they also considering to dispatch engineers. So this is team effort from Japanese industry. So our nuclear designing Hitachi Vernova and also construction company involved in the BWRX-300 project together.
Thank you for the presentation. My question's to cost and cost efficiencies in future deployments. So some might say 6.1 billion Canadian dollars for 300 megawatts is too expensive and nuclear doesn't compete well. Right, with each future unit's deployment, you're going to get efficiencies in the cost of each unit's deployment. But how is the strategy to take those cost savings, and this really building off, I think, the question Marty was asking, those cost savings from the Canadian project to other markets where you're going to be utilizing new workforce, right? There'll be new local workforce, and then there'll be likely imported workforce to deploy the technology. Can you describe your strategy at all to leverage those learnings, and then maybe describe a little bit of what your future cost per unit is targeted at when you consider kind of an nth of a kind deployment?
Yep. So because of the first project, of course, we have a time constraint, and all of the entities fast trial, so relatively cost will be increased. But in parallel, we are not waiting for completion of the first unit. In parallel, we also discussing how to reduce the cost for the future unit, and also we have several approach to reduce the cost. And then, but key point is BWRX-300 approach is we maximize the standardized design. So we apply the, for example, the seismic load. Right? Seismic load, basically each location has each different, right? But our BWRX-300 considering to reduce, like we apply the carefully decided the seismic load that can be applied to the several site location. That way, future unit engineering cost, we don't need to repeat it engineering work. And manufacturing, to proceed with the first unit, in parallel, we also developing the supply chain. And like the multi-supply chain should be important to expand the deployment globally. So there are several approach. Then we also in parallel consideration for supply chain development, and also as I said, this is a standard design approach. So NS of kind project, we have already proven spec for supplier. So we can just provide specification, detailed specification. So future supplier just follow this specification. So no deviation, right? No unexpected problem occur. So it's contribute to reducing the overall NS of kind cost.
Okay. Thank you, Mr. Sakamoto-san.
Thank you very much.
Yeah. Excellent update.
Thank you.